All right, so the last couple of days we've been looking at number sequences, number patterns. We've been finding out what the patterns are and trying to write models for them, mathematical models. So we're going to continue doing that a little bit today, but we're going to look at some specific types of patterns, some specific types of sequences. The first one that we're going to look at today is arithmetic sequences. All right, so let's go ahead and look at it. We're going to try to look at the pattern. We're going to identify what the pattern is. We're going to try to create a model or an equation that allows us to find a specific number or specific term of the sequence. All right, and so then we'll go from there. So here's our first sequence, 2, 5, 8, 11, 14. All right, so again, we're going to try to be determining a specific term, say the 10th term of the sequence. So what are some pieces of information that might be important in order to do that? Well, hopefully you would say, well, we're going to need to know the difference between each of the terms. What is the pattern? All right, so we need to know the pattern. What else do we need to know? Well, we need to know where we started, right? You need your starting point. Okay, and then last of all, we need to know exactly which term we're looking for. Okay, so those are the three things that are going to be important, and we're going to try to incorporate that into our mathematical model. So let's first ask ourselves, what is the pattern of the sequence above? Well, hopefully you recognize that we are adding 3 each time. All right, now that we understand that we're adding 3 each time, let's write down the first few terms and how we get them. But let's try to incorporate what we have up here, the pattern, the starting point, and which term we're looking at. Okay, so the first term, which is U1, is going to be 2. Okay, that's our starting term. All right, so then let's go to the second term. And the second term is 5. Now, how did we get that 5? Well, we took 2 and we added 3. Okay, well, let's go to the next term. So now let's go U3, the third term. The third term is 2 plus 3, which was the second term, but now we're going to add 3 to that one. Okay, you see what's happening here? Rather than writing 2 plus 6 or writing 5 plus 3, we use this idea of our starting point, and we said, well, I'm going to add 3 and then do it again for the third term. So now let's look at the fourth term. So U4 is going to be 2 plus 3 plus 3, because that's what the third term is, and then I'm going to add 3 one more time. And so hopefully you can recognize now this is 2 plus 3 times 3. This one, so here we go, so this is equal to 2 plus, and then 3 3's. This one is 2 plus 2 3's. This one is 2 plus 1 3. Now if we're keeping with the pattern, this would be 2 plus 0 3's, right? Okay, so now we can see a pattern. Here, this 2 is the starting point, which we said was going to be important. This 3 right here is the pattern. That's the plus 3 each time, right? So now this number seems to be the only thing that's changing as we go from one term to the next. So how is that number related to the number of the term? Well, when it was the first term, it was 0. When it's the second term, it was 1. When it's the third term, it's 2. So at this point, we can now recognize that this number right here is going to be 1 less than whatever term it is. So now at this point, we're going to define some variables. Okay? Now, for this type of sequence, the pattern is going to be adding the same thing every time, or subtracting the same thing every time. This is going to be what's called a constant difference, or a common difference. So this is D. All right? Now, the starting point. The starting point is going to be the initial term. So U1, right? The first term. And then which term are we looking for? That's going to be the nth term. So that's n. So now, from the pattern that we have above, can we now determine a general equation? Okay, so if I want the nth term, this is the general term, then what do I have to do? Well, I have to take 2, which was the starting point, and then I'm going to add. Now this next number was the term minus 1, right? So that's going to be n minus 1. And then the last number is 3, which was d, the constant difference. Okay, so let's go ahead and try another one. Let's do it again with a different sequence. 31, 27, 23, 19. Let's go through it a little bit quicker this time. What is the pattern that we see? Well, to go from 31 to 27, I'm going to subtract 4. To go from 27 to 23, I'm subtracting 4 again. So each time I subtract 4. So subtract 4 each time. Now, similar to what we did before, let's write down the first few terms and how to get them. Again, we want to pay attention to that starting number. We want to pay attention to the pattern, and then pay attention to the number of the term. So the first term, u1, is 31. The second term is 31 minus 4, because I'm subtracting 4 each time, right? The third term is 31 minus 4, because that's u2, and then I'm going to subtract 4 again. Okay, now hopefully, because 31 minus 4 is 27 minus 4 is 23, hopefully you're going to recognize that this is very, very similar to what we were just doing, except this time it's going to be subtracting 4 each time. All right, and so there you go, 31 minus 4 minus 4 minus 4, and so again, we should, from this pattern, be able to write a general equation. So the nth term, right, this is 31 minus 4, this is 31 minus 2 times 4, this is 31 minus 3 fours. Okay, so that 4 would of course be 1 4, so 3 fours, 2 fours, 1 4, and 0 fours. So again, we see the same thing where this number right here is the term number minus 1. So un equals 31, which is our starting term, and then minus n minus 1 times 4. Okay? Now, we can compare this to what we have up there, and they're almost exactly the same, with the exception of this plus right here and its minus right there. Now, we can actually take care of that by distributing this minus to the 4 and making it a plus and going, okay, well, instead of that, you learned back in Algebra 1 that that's the same thing as plus a negative. And now you notice that this negative 4 matches the pattern that we recognized before. And so at this point, we're going to note that the two are similar. This is what's called an arithmetic sequence because it has a constant or common difference, as I mentioned before. Now, think back in chemistry. How do we find the difference, since I'm calling this a constant difference, how do you find the difference in two terms? Well, hopefully you know from either chemistry or some other class that it's always the final minus the initial. So the second number minus the original one. So if you note right here, 27 minus 31 would give us negative 4. 23 minus 27 is negative 4. 19 minus 23 is negative 4. And so we get the same difference every single time. Now, if we get the same difference, then it is what we call an arithmetic sequence, and it will follow this pattern. Now, the pattern that we noticed, one of them is that the nth term is going to be equal to, and in both of our equations, this first number was your first term, so u1. And then we had this plus n minus 1, but depending on what term it is, right? If I wanted the 10th term, I could put 10 in for n. And then the last number was that constant difference. What was the pattern, right? In this case, it was negative 4 because each time we subtract 4. So this is going to be, as I identified at the beginning, d. what that constant difference is, the pattern. So that's one equation. The other equation that we're going to use a lot with arithmetic sequences is this one. We just talked about how you take the second number and subtract the first one. So if I want to find out the constant difference of any arithmetic sequence, I take a number, un, and I'm going to subtract it from the number that comes after it, right? So that needs to be subtracted from un plus 1. And so I subtract that from what I initially had, and that would equal the constant difference. Un plus 1 minus the number that came before it, right? Final minus initial, gives us the constant difference, or the common difference. All right? So that's the basic idea behind it. I'm going to stop this video here. The next one will go through some examples. All right? Cheers.